Hi, this is Ben here, and in the following video, I will be proving Archimedes principle. Using Archimedes principle to prove if a ice cube melt in the water, is it going to affect the water level or not? So in the first page, I had equations here, and since buoyancy equals to rho equals to rho times g times v, and v is the area of the container times the delta H. So we got the delta H in the form of m over rho of water times A. And this is the delta H before and after putting an ice cube in. And as you can see in the video here, I put three ice cube in the water, and after that the water level goes to 4.1 centimeter. And after the ice melts, the mass of the ice becomes the mass of water, but the volume of it is going to change because the density is different. So we have the equations here, and we found out that delta H prime equals to m over rho water times A, which is the same as the delta H before, which means the water level is not going to increase or decrease after the ice cube melts. Due to some technical issues, I cannot make a ice cube without any air, and also I cannot make a ice cube with large volume of air inside. So I can only do the ice cube without air part, but I still do the equation part as you can see here. The first part is the same as before, but we need to include the mass of the air in the gravitational force equation. But after the ice melts, the air is not going to convert into water, so the delta V will only have the mass of the ice cube. We have the delta H in this form, and after subtracting the delta H and the delta H prime, we can get that the difference is actually larger than zero, which means the water level will fall. And the third part is we have an iron mass. I put a iron mass in the ice, one of the ice cubes. I put in two ice cubes just to make sure the difference is large enough to observe. And we have the equations here, which makes the delta H equals to m of the ice plus m of the iron over rho water times A. And m iron is equals to rho iron v iron. This will be used in the following, but we won't be using it right now. And after the ice melts, the iron mass is now sinking in the container. So the delta V is will be equal to the volume of the ice becoming water plus the volume of the iron. And after a couple of substitution, we have delta H prime equals to this one. And then subtract the delta H with delta H prime. And after a couple of steps, we got this equation here. The final result is equal to rho of iron over rho of water minus 1. And this times the volume of iron over A. And we all know that the density of iron is larger than the density of water. So the fraction there is larger than 1, which makes the difference is larger than 0. And this is also meaning that the water level will fall if we have a iron mass inside the ice cube. So here I put in the ice cube with iron mass in it, and after I putting it in, the water level stays at 4.1 centimeters level. And after it melts, we found out that the ice level drops to 4.05 centimeter, which decreased by 5 millimeters. Therefore, I have used Archimedes' principle to successfully prove that water levels movement after the ice cube melts on it. Thank you for watching, and that's it.